Welcome back, my dear friends, to your channel of learning mathematics. Remember last time what we did? Understanding quadrilaterals. That everybody knows, but quadrilaterals, we discussed about quadrilaterals. We were just talking about some basic things. You remember that? What were the basic things? It's all given in the board before. Alright, let's do a quick recap. So, once again, welcome back all of you to your channel of learning mathematics. I'm going to be doing understanding quadrilaterals, but today also we are not going to be doing much of quadrilaterals. We're still going to be continuing with polygons, and I will be trying to solve the exercises of some exercises of practice questions of polygons. Also, I will be using the textbook of Progress Publishers. That will be chapter 13 under that particular textbook. But doesn't matter, the concept matters. So whatever exercise we do, but yes. If we look back, once upon a time, in the last class, what we did was, you can check back the video also, I'll provide you the link below also. We first talked about curves, and guess what? Today I'm going to give you some very interesting formulas, shortcut formulas also to find out like diagonals of a polygon. Wait and watch. Alright, so I'm going to give you some very interesting formulas, shortcut formulas to quickly find out the answers also. So, alright then, pick up your pen, paper, books, that same old rough copy where you've written down the previous notes, and chala, let us begin. So, last class we started with curves. Simple curves, complex curves, open curves, closed curves, basic things, right? Plane surface. Then yes, the main part was polygons. So under the topic of polygons, we introduced interior and exterior parts of polygons. I'm not going to be discussing that in detail. As I said, it's all in the first video. You can kindly go and check it out. Diagonals of a polygon, regular and irregular polygons, right? If you remember, regular polygon means all the sides are same, irregular means all the sides are not same, of course. Convex and concave polygons. Types of polygons. This was interesting. Types of polygons we had depending on the number of sides. So if we have that polygon has 3 sides, it is called a triangle. If it has 4 sides, it is called a quadrilateral. 5 sides, pentagon. 6 sides, hexagon. 7 sides, heptagon. 8, octagon. 9, nonagon. 10, decagon. So that was what was studied in the last class. So today, 2 more properties of polygons we are going to be studying, and after that we will be solving some exercises. Ready? Chalo, pick up pen, paper, books, and let's begin. The first topic that we are going to be doing today is sum of interior angles of a polygon. What was a polygon, by the way? Polygon is any figure which is having sides, no? Joined by straight lines. Isn't it? So that's why we have these different kinds of polygons. I tell you, no, you go through these videos properly, serially, systematically, I'll tell you, you will never have any more problems in quadrilaterals, guaranteed. But yes, you also have to practice and you also have to work hard. Okay. Alright. Okay. So today we're going to be, first topic that we're going to be studying is sum of interior angles of a polygon. Interior angles of a polygon means, for example, like I have a polygon 1, 2, 3, 4, 5, maybe 5 sides. Alright, so interior angle means the inside one angle only. So this is one angle. This is one angle formed. An angle is formed where the 2 sides meet at the vertex point. This is one angle formed. This is one angle formed. So how many sides? First of all, 5 sides, pentagon. How many angles? Interior angles are formed. I'll just write in short. How many interior angles are formed? 5. So you can see very clearly, one thing is already clear, that the number of sides will be equal to the number of interior angles. Alright, so that's the first thing that we will be learning. Okay, I'll just give you number of first point, okay, first basic point. Number of interior angles of a polygon is equal to the number of sides of a polygon. Got it? That's the first thing that we are going to be learning today. I mean, already learned, but so again, number of interior angles of a polygon is equal to number of sides of a polygon. Okay, na? Alright, next is, what will be, no, second point, what will be the sum of all the interior angles of a polygon? Now that nobody can tell because it will depend on the number of sides. This might be distracting you, so I'm going to rub this off. Of course, don't forget pentagon 5 sides. So that is given by, I'll just write here, it is given by n minus 2 into 180 degree. Now what is n? N, what is n? N is number of sides that our polygon has. So this is the second point, that is the sum of the interior angles of a polygon. If you want to find out, you will find out using this particular formula, that is n minus 2, n represents the number of sides of that polygon, into 180 degree. Alright, let's take an example. Let's say we have a pentagon. 1, 2, 3, 4, 5. So what will be the sum of interior angles of a pentagon? How many sides do we have? We said 1, 2, 3, 4, 5. We have 5 sides. So 5 minus 2 into 180 degree. So that's going to be 3 into 180 degree. So that's going to be how much? 0 for 540 degree. And that's the way we will be calculating for any kind of polygons. We can find out the total of all the interior angles combined together. This plus this plus this plus this plus this. Even if we have 5, 6 sides, accordingly we will be finding out. Alright, that is the first topic for today. Keep that in mind. Okay, we will do that. We will do some practice questions later on. The second topic that we will be discussing is sum of measures, M-E-A-S-U-R-E, sum of measures of exterior means outside, na? Exterior angles of a polygon. Exterior angles. Now before that, let us learn what do we mean by we have already done lower classes, but revision to banta hai, chalo. Exterior angles of a polygon. What do you mean by exterior angles of a polygon? When we extend one side of a polygon, only on one side, we cannot do that on both sides. Condition is that. Then an exterior angle is formed. What did I just say? What is this guy talking? I'll give you an example. Suppose I have a polygon like this, 4 sides, okay? How many sides? 4 sides. Now, what condition is, you will be extending any one side, but only on one side each. I cannot like, nah. You can't do that. You will not be doing that. Condition is that. So I'll just extend, okay, this side, this one, I'll just extend to this side. So when I extend this side, see, these are interior angles, na? Inside. So inside ones I will shade like this. These are interior angles. So 4 sides, so we have 4 interior angles. So exterior means the angle that is formed outside when a line is extended. Similarly, let us try to extend this angle, maybe on this side. So another angle is formed. Alright, now this side I will extend this way. Another angle is formed. And one more side is left. This one I'll extend on this side. So another exterior angle is formed. So you see how many exterior angles is formed again? 1, 2, 3, 4. So these are called exterior angles, outside angles, when we extend one side of a polygon. So how many sides did we have for this polygon also? 4 sides. How many exterior angles did we get? 4 angles, 4 exterior angles. So here also, first special condition that you get is number of exterior angles of a polygon is again equal to the number of sides of a polygon. Okay, so that is one condition. Number of exterior angles that a polygon can have is equal to the number of sides in the polygon. So 4 sides, 4 exterior angles. Second is, what will be the total, I'll just write like this, total of exterior angles of a polygon. Here no formula, it is fixed. It is always, forever and ever. Always 360 degree. Even if you have 5 exterior angles, 360 degree. You have 10 exterior angles, total will be only 360 degree only. Alright, so 360 degree only. That is fixed for exterior angle. Okay, my dear students, so this is what we will be, what we have for the introduction of the first topic. So basically there we have already now learned almost everything about polygons. Now time to do some exercises. Alright, so let's get ready for the exercise from Progress Publishers textbook, that is exercise 13.1. Get ready, chalo. Alright, so these are some practice questions. As I said, I have taken these questions from Progress textbook of Progress Publishers, but it's not about the textbook, it's about concepts. Even preparation for competitive exams also very important. Okay, these topics. Now, alright, let's get back to the point. Exercise 30.1, the first one. Identify the type of polygon and write its name. So please don't mind my figure, I'm very bad in drawing. So the first one, how many sides do we have? Let's count the number of sides. So this is 1, 2, 3, 4, 5, 6, 7. So we have how many sides? 7 sides. So what do we call a 7-sided figure? Check the notes quickly, check. What do we call it? We call it heptagon. H-E-P-T-A. I'll just fit in here. Okay, heptagon. We will be calling it a what? Heptagon. 7 sides, no. So it's called a heptagon. What about the second one? Number B. How many sides? 1, 2, 3, 4. So what do we call it? Q-U-A-D, quadrilateral. I'm just fitting it here. Quadrilateral. Q-U-A-D-R-I-L-A-T-E-R-L. Because it has 4 sides. This has 7 sides, this has 4 sides. Alright, this one how many sides? 1 side, 2 side, 3, 4, 5, 6, 7, 8. We have 9 sides. So what will we call this? Nona. N-O-N-A-G-O-N. What a name. Okay, nonagon. N-O-N-A-G-O-N. Nonagon. And the last one, how many sides? We have 1, 2, 3. So this one everybody knows. This is called a triangle. So that was not very difficult, isn't it? So it's just about the number of sides. Ho gaya? Pause the video there. And write down. Okay? Alright. Let's check out the second question. Fill in the blanks. So here I'm going to give you some interesting formula. First one though already given. What is the first one? Number A. I'll solve here. Okay? The sum of interior angles of a pentagon. Already solved. The sum of interior angles of a pentagon. How many sides do we have? We have 5 sides. So sum of, I'll just write in short, in short only I'm writing, interior angles. Sum of interior angles will be, what was the formula that I gave you? N minus 2 into 180 degree. So that's going to be 5 minus 2 into 180 degree. Writing down now quickly, 3 into 180 degree, how much? 540 degree. 540 degrees. So the sum of the interior angles of a pentagon is 540 degrees. Ho gaya? Finish? Alright. Now pause the video. You can pause the video and write down. Okay? Alright. Now here I'm going to give you one interesting formula. The number of diagonals in a hexagon is, now this one too we did not, the formula, any formula was not given. Number of diagonals. We just learned about diagonals. Diagonals means when we join 2 sides which are not adjacent, like here and here we can join, here and here we can join, but this and this too we cannot, it's a side only. So for example, like this also. So like 1, 2, 3, 4, you know. But like every time it's not very easy now to find out by drawing. It will get confusing though. So that's why I am here now. Write down a formula. I'm going to give you a formula which will be very useful for the rest of your life, even for competitive exams also. Write down. I'm going to give you a formula that is number B. Okay, you can give it to your elder brothers and sisters also. Hey, look, study this for your competitive exams. Number of diagonals of a polygon. Number of diagonals of a in a polygon is n into n minus 3 divided by 2, where this n means, we have already discussed, this n means number of sides of that particular polygon that we are talking about. Now here what are we talking about? So let's use this formula and get the answer. The number of diagonals in a hexagon. Hexagon, how many sides are there? What will be n? Hexagon, count. Hexagon, how many sides are there? We have how many? 6 sides. Hexagon means 6 sides. So just use this formula. So n will be 6 into 6 minus 3 divided by 2. So this one we can cancel. 2 1s are 2, 2 3s are 6. So this is going to be 3 into 6 minus 3, 3. So 3 into 3, how many? So we will be having 9 diagonals. Like that you can find out for any kind of a polygon. Just use this formula. You can give it to others also, to your elder brothers and sisters who might be preparing for competitive exams and all, NPSC, UPSC exams and all. Very important formula. Okay? Alright? Finished? Rubbing off? Chalo. Next one. What is it? The interior angles. The interior of a polygon. Any polygon, let's say like this. The interior of a polygon and its boundary are together known as polygon only. Actually we call it region. Okay, it's polygon region we call it. So perfect answer will be polygon region. We call it the region combined together along its polygon. So we actually call it polygon region. The region of that polygon. Polygon region. Alright? Polygon region. Area. No? Polygon. Not area. Polygon region. Okay, that's better to write. Polygon region. Alright? Okay. There's one more there. Let's quickly write on that. What is that question again? Another one that we have here is a polygon. Number D. Very easy one. A polygon in which, these are very interesting questions. A polygon in which all sides are equal. A polygon in which all sides are equal is called a what? What do we call that? In which all sides are equal? Regular, na? Regular polygon. When the sides are not equal, we call it irregular polygon. We already studied, and this one we call it a regular polygon. Alright, I'm reminding you once again about third point. Third sentence, that is, the interior of a polygon and its boundary are together known as polygon. But better we write polygon region. Better we write polygon region. That's more appropriate. Okay? Alright then, let's move on to the next question. Alright, so moving on to the third question, that is, state which of the following sentences are true or false. First one, the sum of the exterior angles of a hexagon is 720 degrees. True or false? Remember I told you something. What was it? When you talk of exterior angles, no matter what shape the polygon is, no matter what shape, hexagon, heptagon, whatever gons it be, it is always How much? 360 degree exterior angle, always 360 degree, no matter how many sides, what shape the polygon is. So this one is straightforward, no need to calculate also. Patapuri, false. No need to think about it also. Alright, okay, now number B. The sum of the interior angles of a quadrilateral is, this one is finished, I'm rubbing it off. 1, 2, 3, 4, 5, 6, 7. I need some space to calculate. Nah? The sum of the interior angles of a quadrilateral is 180 degree. That too I can't say. I'll have to calculate. What was the formula? N minus 2 into 180 degree. So when you talk about quadrilateral, how many sides we have? 4 sides. N is 4. Nah? Quadrilateral means 4 sides. N is 4. So 4 minus 2 into 180 degree. This is a universal theorem, of course. 180 degree. How much is it? 360 degrees. So it is true, isn't it? And not true. This is also false. False. We call it what? False. Not true. False. Okay? Alright, so this is also done. You can pause the video and then write down. Third one, the number of diagonals in an octagon. This one also I gave you the formula. What was the formula? N into n minus 3 divided by 2. That was the formula that I gave you, isn't it? To find out the number of diagonals in an octagon. So in an octagon, how many sides are there? Octagon. How many sides? Octa. How many sides are there in an octagon? We have how many sides? 8 sides. So let's use 8 into 8 minus 3 by 2. 2 ones are 2, 2 fours are 8. So 4 into 8 minus 3, 5. 4 fives are how much? 20. Ah, yeah, this one is true. Finally, all false. Chalo, and this one is true. Alright. Next, all interior angles of a regular means all sides are same. No? Regular heptagon are equal in measure. All the interior angles. Heptagon means 7 sides. So 1, 2, 3, 4, 5, 6, 7. 7 sides. Heptagon means 7 sides, isn't it? Right, so heptagon means 7 sides. So interior angles 1, 2, 3, 4, 5, 6, 7. What they say is that sum of all the interior angles combined together in a regular heptagon, not sum, sorry. All the interior angles of a regular heptagon, they are all equal. This is all equal in measure. What it is? True. And this is true not only for a regular heptagon. Regular means, remember, all sides are same. So this is not only true for a regular heptagon, it will be true for any regular polygon. For any regular polygon, all the interior angles will be equal in measure. Pentagon, octagon, nonagon, decagon, whatever be the polygon, as long as it is regular. Regular means all sides are same. So as long as all sides are same, yes, all the angles will be equal in measure. Got it? Chalo. So one last question that we will be doing. That is number 4. That is identify. This one I'll just write. Identify the concave and convex polygons. Let's just do it quickly. I've written the question in short order. Identify the concave polygons. The first one is an arrow mark. So like 1, 2, 3, 4, 5, 6, 7. Second one, that's like 1, 2, 3. 1, 2, 3. Then like chunga, 5. Third one is something like this. Forget about the figure, okay? This. And then it's something like this. Something like an arrow mark only. My drawing is horrible, so please don't mind. And the third one, you can just check for yourself and guess if it is correct by the time I finish the figure. One, at least for this one, be patient. Yeah. Alright. Let's just finish this strip, no space. Chalo. So this one, concave, convex. What was concave and convex? Concave means you take any two interior points. Convex means any two interior points, and then when you try to join the interior points, it should not go outside, then it's convex. But if it goes outside, it is concave. Now look here, this. I join this and this, no problem, interior only. But this is one interior point, this is one interior point. I try to join this, definitely it will go outside. Isn't it? That is what we mean. So this is called, this will be concave. Now, again, I will try to join this point and this point. There's only one we have to go outside. Some will be interior, but you will see some points, so they'll have to go outside. But here, there's absolutely no chance. Wherever you take the points, wherever interior you take the points, you join them, all will be just interior. Inside only they will be joining. So this is convex. And what about this one? Here and here, if I join, chalo, no problem, interior. But when I try to join one point here and one point here, yeah, I'll have to go outside though. Uvai nahi hai. So this becomes concave. Okay, and the last one, the last figure that we have. So, okay, I have enough space here. Chalo, almost done. Last figure that I have here is number D. That is one more figure that is like this, like this, like this, arrow, pointer, pointer, like this, going down. Okay, this one is again going on. This one, babri. Okay, something like this. Now, tell me, this is a concave or convex? Any two, you just like this, chalo, no problem. But what about this and this? I'm going outside. What about this and this again? I'm going outside. What about this and this? I'm going outside. So this is also concave. So there was only one convex polygon in this figure. Alright, so that's it for today. The remaining, in the next, I'll come up with another video again where I'll try to solve the remaining part of the exercises, and which is going to be really good practice for all of you. So if you have liked this, please do comment, know that you have liked the video, and do give me a like and subscribe also. Alright then, till then, take care, see you, stay safe, stay home, stay strong, and study well.